say 1 carbon away. So it's -2. So the way carbonyls work, I know they're a little bit confusing, but the carbonyl, you're kind of counting this whole, you're not looking at the oxygen for a carbonyl, you're actually looking at its whole functional group. So because this carbonyl, the whole functional group is 1 carbon away, it's 1 carbon. If we were if this was a single bond to an oxygen, for example, so say this was like a hydroxyl group, then it would have been, if this was an OH instead of an O. If this was an OH, then it would be 2 carbons, but for a carbonyl, it gets counted as the functional group as a whole, so it's 1 carbon away. Does that make sense? So we're done with that one. How about losartan? Oh, this is one that you can't estimate yourself. So don't worry about something like this, but in this one, there's 2 basic functional groups here. So both of these amines are bases, so they're going to accept protons. So this one, the pKa is around 7.4. This is an imidazole ring, remember? So the pKa is around 4.1. And this is a tetrazole ring over here. But I wouldn't ask you something like that in an exam, because again, remember I said that you always be wary of nitrogens when they're in or attached to aromatic rings, so the pKa's are a little tougher to estimate. All right, group 7. Andy? So we have this group here, right? So it's 2 carbons away, and then we also have your alcohol, 2 carbons away. Okay, so -2 total.
And another 3 carbons away.
Right. And another one 3 carbons away. So what's that? -1, right? So it's 10.6 -2 -1.
-2.5. 3 carbons away is
Yes. So yeah, these are both -1, -1, -0.5. Yeah, so the aniline, this one, the pKa is super, super low because we have an aniline attached to 2 different aromatic rings. So if it was just attached to 1, you would say, oh, it's probably about 5, but it's attached to 2 rings. So this is very, very low. Okay, you with that one? Moving on. This one we have an amine, right? So 2 carbons, right? And then we also have a 3 carbon. Yep, -1.5. Gets easier as you do them, right? It takes time. Okay, so how about here? We have an amine, right? What are we subtracting? 0. Yeah, nothing, right? Because all of these functional groups are more than 3 carbons away. So this would just be 10.6. Montelukast?
Right?
Oh, no? Yeah, carboxylic acid, right? So what would we subtract for this? So we actually have 1, 2, 3 carbons away. We have a sulfur. So it would be -0.25. And then something that we also have is a nitrogen in an aromatic ring, right? So it's an aromatic ring. So this pKa is pretty low. Yeah, so you would say, oh, it's probably around 5. Sorry. Oh, it's not working anymore. So you would say it's around 5, but I wouldn't ask you to calculate it. Mm-hmm. It's 4.6 is the parent for an aniline, so it's usually around like 4 or 5. Right, so for carboxylic acid, a carboxylic acid attached to an aromatic ring, you only subtract 0.75 from the parent. But this one isn't attached. This is just subtracting the effect of this sulfur group that's 3 carbons away. So for this, aiming again during like a quiz or exam, I wouldn't ask you to estimate this one. You could recognize, if I were to give you, so say there is no carboxylic acid on montelukast, and I gave you this molecule, the only thing I would be able to do is perhaps I could say maybe the pKa of this, and I would give you a pKa value. You would recognize that it could be the base, that this is a base, right? So I would want you to know that this is a base, but I wouldn't ask you to calculate the pKa of it, because it's in an aromatic ring. So these aren't working anymore, guys. Oh, there we go. Okay, so cyclobenzaprine. Actually, remember I said carbon-carbon double bonds are electron withdrawing groups. So we have 2 carbons away is this double bond. So it would be 2 carbons minus 1, 9.6. Yeah, this carbon-carbon double bond.
So on the next one, the amine, is it just to subtract 1?
Right, so the next one now, the sertraline, we have an amine, right?
Yeah.
So what do we account for?
Just the benzene. The
Right.
cyclohexene.
So we have 1 carbon away is the benzene. So that's minus 2.
Oh, okay.
And then this ring here is far away, right?
Yeah.
1,
Just the minus
2, 3, 4, so you're only doing that one.
minus.
Yeah. So this would be 8.6. Okay. Duloxetine. Mm-hmm.
Then mine is 1.5. These are the
3 carbons away. We have this functional group here, right? So minus 0.5. And then we also have this oxygen, which is also 3 carbons, minus 0.5. Yeah, so it would be 10.6 minus 1, 9.6.
You had done one a little bit above, I don't remember which one it was. 3 carbon, I know I had taken out 0.25. So because of the sulfur?
Right, so remember the difference for carboxylic acids and amines.
Yes.
So carboxylic acids, the subtraction is half of what it is for amines. So for carboxylic acid, something that is remember for the carboxylic acid,
Uh-huh.
1 carbon is -1, 2 carbons is -0.5,
Oh, and then 3
and
carbons.
3 carbons is -0.25.
Okay.
And then for amines, it's 1 carbon is -2, it's double, whatever.
And then 2 carbon would be minus.
It goes in half as you go down. Yeah.
And then 3
And then 3
carbons.
carbons is -0.5.
Okay.
Yep.
And then what about like when you had the sulfur? Because the one of them that was attached to sulfur, would that be making a big difference as well?
Yeah, so for this one, for example, this was the carboxylic acid.
Yeah.
So it was 1, 2, 3 carbons away,
Uh-huh.
and then we subtracted 0.25.
Yeah, that's what I was confused about. So you take off 0.25.
Yeah,
Oh,
because it's the
because
carboxylic acid.
acid. Okay. Okay. Understood.
All right, last one, guys. Tramadol.
I have them. And
1, 2, 3 carbons, right? Minus 0.5. And then what else?
we have them.
Yeah, benzene, 3 carbons, minus 0.5. So 10.6 minus 1, 9.6. Uh-huh.
Sorry. When you the benzene 3 carbons, wait, where do you start counting from? The OH or the?
So you start counting from the carbon next to the ionizable functional group. So in this example, this is our functional group that's ionizing. And then this is 1 carbon. Screen is horrible. Okay, so use the pointer. So this is 1 carbon, 2, 3 carbons. And then this is the group 3 carbons away.
3 carbons away from.
From the ionizable group, from this
Oh, from the
nitrogen.
end. Okay.
Yeah. So we'll stop
So you
here.
look at both of it. So you look at the carboxylic acid and the.
So for this one, you're looking at the hydroxyl group, the OH, as well as
Oh,
this.
and the okay. Okay.